Hi, my dear students. In the last lecture, we saw some introduction about road estimation and we also solved three examples. Now we will continue that. So, example number 4, estimate the cost of earthwork for a portion of road for 400-meter length from the following data. So, they have given formation width B of the road is 10-meter and side slopes 2:1 in banking, 1.5:1 in cutting. So, please see the data here what they have given station they have given. So there are totally 10 stations. Okay, 25 to 35. So distance in meters 1040. So here what we have to look here is what is the difference between the chainages. Okay, what are the difference between the distances. Okay, so we can see clearly that the difference is 40 meters, right? Okay, then RL of the ground, fine, these are the RL of the ground. Then RL of the formation 52 is given, and from there we have to take a downward gradient of 1 in 200. And also they have given that longitudinal section of the road and type of cross section are given in figure, fine. The example can however be solved without the help of electron. Yeah, even the data is given, it can be solved without the help of the L section, because the data is given. No, from that data we can draw the L section and we can estimate, fine. So here it is the L section. Okay, what they have given, what is that L section? So here see, my dear students, so now RL of the ground we saw there are about 10 stations. So distance in meters you have taken 1000, 40, 80 they have taken directly. Okay, 40, 80, 120 till 400 meter it is there. Okay, then RL of the ground they have given 51, 50.90, 50.50. These are the RLs. Formation level they have given for a station at 25. Starting they have given the formation level that is 52 and have told that the gradient will be downward gradient that is 1 in 200. So 1 in 200 means how we have to do 1 divided by 200 into the distance. Difference in the distance is 40 meter, right? When we do, we will get a difference of 0.2. 0.2 we will get. Okay, please check it out. Fine. Now what we have to do, RL of the formation we get 52. We have to subtract 0.2 till 400 meter or till the last chainage of the station. Okay, so 52 is there. So minus 0.2, 51.80, 51.60. We have to subtract 0.2 till the last chainage. So after subtracting, what we have to do, we have to find the height of banking, or it may be the depth of cutting. It is height of banking or depth of cutting, and it is decided by the formation line. See here, if we draw the L section we will get the complete picture. Okay, you can draw the L section, also you can estimate here. When we do the addition or subtraction, we will come to know what is going in the problem. Okay, now so RL of the ground is 51 minus RL of the formation. So RL of the ground minus RL of the formation, if it comes positive, here see, RL of the ground is 51, RL of the formation is 52. So 51 minus 52, it is 1, and it is what, negative. When the value is negative, it's for banking. Okay, when the formation level is greater than the ground level, so it is positive value and their banking is needed. So we have to write in banking. It's fine. So 51.80 is 0.90. So till the chainage 1, 2, 3, 4, 5, 6, sixth chainage, we will get banking what, 51.00 minus 50.70, we will get here 0.30, right? 0.30 at the chain edge, and after that 50.80 minus 51.20. Here you see 50.80 minus 51.20, or 51.20 minus 50.80, we will get 0.40. RL of the ground minus RL of the formation, when it we will getting positive, when it is positive value, we will go for cutting. So see, okay, so 50.60, 51.40, 50.60, subtracting 0.80, 0.90, 0.80, so likewise. Okay, just be sure that where is your RL of formation. If it is RL of the formation is greater than the RL of ground, then it is obviously banking. If the RL of formation is in the lower RL of the ground, then it will be cutting. Okay, how this is a common sense. Okay, now after this we will get the height of banking, depth of cutting. Okay, the D we will get. Yesterday problem we solved for D, no? So here we are experiencing the formation line, it is gone, the ground is uneven, so there is partly banking and partly cutting. Fine, so both banking and cutting are seen in this problem. So what we have to do, we have to recognize where the exact cross is going. So here it is, you can see here the road passes from the banking to cutting in between the station 30, that is 1200, here 1200 to 1240. So see here, or station wise we can say that the stations between 30 and 31 the formation line passes. So in this case what we have to do, so here we can see here, wait, so focus here. Okay, what we have to do, we have to just use the simple concept of similar triangles. Okay, see the figure here, this is nothing but the cutted figure, this is the formation line. Okay, this is the formation line, this is the ground surface. Okay, so this difference is what, 0.3, here we are getting, this is 0.3 in banking section, then above that 0.4 we are getting this value, this is 0.4. Okay, for cutting. Okay, by the similar triangle concept here, 0.3 and this is x, that we know that this difference between the station, that is 40. Okay, so one side we will estimate as x and another side will be 40 minus x. Then by similar triangular concept we have to find the value of x. So here x by 0.3, x by 0.3 is equal to 40 minus x divided by 0.4. Okay, then 4x is equal to 0.4x equal to 0.3 into 40 minus x. When we solve for x, we will get x is equal to say 17 meter. Therefore length of the banking portion is 17 meter. So from the 30th station to till 17 meter we have to do banking, and after 17 meter we have to cut the earth so as to make level for the formation line. We have then we have to cut for what, 23 meters. Till 17 meters we have to do banking, and after that for 23 meters we have to cut, we have to do cutting for the earth. So now with the same tabular column, so b is equal to 10 meter, s is equal to 2 for banking, and s is equal to 1.5 for cutting. So here's the tabular column is same. So now see station 25, 26, 27 same station, but where the banking and cutting crosses, no, there you have to take another reading. So this is important in this. So this step is very important. If we forget the steps, then the answer will be wrong. Okay, so 25 to 30. So 25 distance is 140, 80, 120. Okay, why these distances are taking? Because we got a distance of 17 and 23 where we have to change our values, right? So we are also defining the distance. So height, mean depth d, central area bd, area of the sides s into d square, then total sectional area bd plus sd square, distance between the stations. So quantity, either it is banking or cutting. This banking or cutting we already know in the while we finding the RL. Fine. Okay, now for 25, station number 25. So first column will be blank. For difference it is 1. We will get the height we will getting as 1, height or depth, height of the bank 1. Okay, from 26 change the calculation starts. So 40 meter is the distance. So height of the bank is 0.90. So then for mean height we have to take average of 2, 1 plus 0.90 by 2, we are getting 0.95. For this 0.95 we have to multiply with b, that is 9.50. Then area of the sides sd square. Here till the banking is there, for banking s value is 2, so 2 into d square 0.95 whole square. Fine. Next, total sectional area, this both column we have to add bd plus sd square, then distance. So then the value which comes we have to write in the banking. So by the same procedure we will do till the chainage or the till the station number 30. At 30 what we do? So height of the bank we getting as 0.30. Fine, 0.30. Then take the difference 0.45, take the average, we'll get 0.45. Then for 0.45 into 10, 4.50. Then for 4.50, okay, then s is 2, 2 into d square, sd square will get total area, then distance between, then we will get the banking. For 17 meters, for another 17 meters after the station number 30 we have to do banking, that we have to take down now. So 217. Here for height of the bank or depth we have to take it as 0. And for mean depth, what is the RL of the previous one, 30th? So we have to divide it by 2. Okay, I am talking about the value of this 0.15. How it is getting? We have to divide 0.30 by 2. So we are getting 0.15. Then again the procedure continues. 1.50 into 10, then sd square. Here sd square is 2. Okay, bd plus sd square, so the same value repeats. So after that we are getting 31, station 240.40, we are getting 0.40 we got. So next 0.40 by plus 0 by 2, it is 0.20. Here negative sign indicates that it is cutting, the formation is going to be cutted. Okay, negative sign indicates cutting. Then 0.20, then b into d. Here s is equal to d square, but s value of s is taken as 1 and half. S into 1 and half into d square. What is d? This 0.20. Okay, then again the procedure is same. 17. Then this 31 is up to the distance between the station from last station, this is 17 and this is 23. Okay, here you have to be careful. 23. Then it is for cutting 47.38. Then the same procedure follows. Okay, take the mean value, then multiply with the formation width, then area of the sides, total section area, distance between the stations, quantity. So for total quantity we will get for banking 1821.95 cubic meters and cutting is 1384.98 cubic meters. Now for cost we have to do separately. So we have two items now, item number 1 and 2, particulars of the item: earthwork in banking, earthwork in cutting. Okay, earthwork in banking 181.95 cubic meters, the rate is 275. Okay, the rate is 275. Then percentage cubic meter 5010.36. Then earthwork in cutting, the rate is 350 rupees. Fine, these are the given values in the question. The rate will be given, don't worry. Then 350. So for which the rate is given, that rate we have to take. Then it is 4847. Then make the total 9857 will be the total. Then for this total add 3% contingencies and 2% work charge establishment. Directly you make contingencies as 5% contingencies for 9857, then you will get a value. Then when we add we will get the grand total as 10,350.68 rupees for cubic per cubic meter. So this was an example number 4, which is a different problem. Here we can see both cutting and filling is concept have come in this problem, and example number 5 is for your assignment. It is also easy, same procedure. Fine, same procedure, same similar triangle concept. Okay, you try it once. Now we'll go for another concept called vertical drop in ground. So while surveying for road, in some cases we experience a sudden drop in the ground. Okay, while in the survey line where we are surveying, we will get a sudden drop like this. See the figure here. So this is the ground level. So here is the sudden drop. Then again the ground is continuing. Okay, for this sudden drop, if we experience for this sudden drop, what we have to do? So there is a procedure for this type of problem also. So now I'll read. Whenever there is a vertical drop in the ground at any point, there will be two reduced level. What he is saying, whenever there is a vertical drop, what we have to do? We have to take two RLs of the ground at that point. At this point we have to take one RL at this point and another RL at this point. We have to take two RLs. So in calculating earthwork, the portions on either side of the vertical drop should be dealt in two operations. One by taking the mean of the two consecutive heights or depths up to the point, and other by taking the mean of the two consecutive heights or depth beyond this point. So you will understand when we go through a problem. So in the first operation, one of the RL at the vertical drop together with the previous RL, one of the RL at the vertical drop together with the previous RL should be taken into account, and in the second operation, the RL at the vertical drop together with the subsequent RL should be considered. This will further clear from the following illustration. Okay, there may be, so in this problem for the same ground we are taking three cases: case 1, case 2 and case 3, where case 1 the formation line is given at 52.50, means it is very much higher than the ground level. Before that I'll show the chainage. So the chainage are 10 station, 10, 11, 12, 13, 14, 15 till 15. So there are 6 stations. Okay, the distance between them is 50 meter is the distance. Okay, so you can see 500, 550, 600, 650. Okay, so the RL of the ground is 50, 50.60, 50.30, 48.50. Why the RL is taken here? Because here there is a drop. Okay, for the station at 12 there is a drop, so we have to take at either side, at top and at the bottom. We have to take two RLs. So 50.30, 48.50, next 47.90, 48.20, 48.00. Now the RL of formation. So for illustration they are giving that case 1, so 50.50, which is greater than the ground level. So if this formation line if we take and it is given as 1 in 100, the road is full in banking. Okay, and here you see the case 2. For case 2 the RL given is 48.00, where the RL is below the ground level, and here we'll experience only cutting. And case 3, the RL is given at 49.50, where we can experience both here banking and cutting. So fully both banking and cutting can be seen here. So we will solve this problem, we will understand the consequences. Okay, so now first one, case 1. So please students, remember this diagram. Okay, remember this diagram or take a screenshot of this in your mobile, or I'll share the PDF also. Okay, take the screenshot of this diagram so that understanding will be easy. Okay, now we will go to the problem. So case 1, fully in banking, where the formation level is, which they have given is, case 1 formation level is 52.50. so 52.50 is the formation level. So 1 in 100, so chain age 10, 11, 12, 13, 14, 15. Okay, so it is downward gradient, it is 1 in 100. So 1 in 100 means how we have to do, 1 divided by 100 into 50. So what we will get, we will get around 0.5. Okay, 0.5 we will get. So 0.5 difference we will get, that is formation is in downward gradient, and 0.5 in downward gradient means we have to subtract. So RL of the ground given 50, 50.60 for 12th chain age. So we have two RLs as I told before only, because one RL is taken at the top and another RL is taken at the bottom. Fine. So 50.30, 48.50, so 47.90, 48.20, 48.00. This is given RL of the ground. So RL of the formation they are given at the 10th station, that is 52.50. Now we have to subtract how much, 0.5. We have to subtract 0.5 because ground downward gradient is 1 in 100. Okay, when we subtract, fine, when we subtract we will get the height of the bank, that is RL of the ground minus RL of the formation. So here the formation level is greater than the ground, so we will get in all the values in banking. Okay, all the values will get in banking. So 52.50, then it downward gradient 1 in 100, 52, 51.50. Fine, then height of the bank, so it is 2.50. So 1.40, 50.60 minus 50, 52, 1.40. Here 50.30 minus 51.50, you have to take 1 height of the bank. Next 48.50 minus 51.50, we will get 3. So here we have, because of the two values, we will get two height of the banks. One is at the for upper RL and one is for the downward RL. Okay, then for 13, 3.10, 2.302. Now while taking mean, this procedure we have to find. So 2.50 plus 1.40 divided by 2, we will get the mean height of the bank. So here for 12th station, so 1.40, this value plus this value 1.20 divided by 2, we are getting 1.30. Then this value is carried out to the next station, next 3. Okay, the value 3 plus 3.10, these both are added and the average is taken for mean height of the bank for the 13th station. Next, as usual, 3.10 plus 2.30 by 2, next 2.3 plus 2 divided by 2, 2.15. So this was the procedure for mean height of the bank. Height of the bank, if we get these values, we can tabulate as we did earlier for all the problems, and we can find the cost. Now case 2 for fully in cutting. For fully in cutting, they have given the formation in downward gradient, that is 1 in 200. So 1 divided by 200, 1 in 200, 1 divided by 200 into 50, we will get around 0.25. So what we have to do, we have to subtract 0.25 from the RL of the formation, which is given at the station 10. Fine. So RL of the ground 50, 50.60, same as we wrote in the earlier problems. So RL of the formation they have given as 48. So now RL of the formation given as 48, so it is lesser value. It is the RL of the formation is below the ground level. So whatever the value we will take here is a all we will cutting values. Okay, cutting values. So 50 minus 48, it is 2. 50.60, 2.85. So here 50.30 minus 47.50, 2.80. 48.50 will minus 47.50 will get 1 and 2. We will get two values as we have two RLs. So same, we have to subtract point. Okay, we have to subtract. Then for mean depth, same 2 plus 2.85 by 2. Then for the mean height at the 12th station, what we have to do, we have to take this first value and the previous value, we have to average 2.825. Then for 13th station, we have to take previous value as 1 and 0.65 divided by 2, 0.825. Okay, we will get the mean depth of cutting: 2.425, 2.825, 0.825, 0.925, 1.225. So now case 3 is partly in banking, partly in cutting. So see the figure. Case 3, partly in banking, partly in cutting. This is the formation level where the road is fully straight. So here we have to do cutting, here we have to do filling. Okay, here we have to do filling, here we have to do cutting. So see the example. So RL of the ground same as previous. The formation level given is 49.50. As the formation level is given 49.50, okay, and the gradient is not given, so it is understood that the RL of the formation is constant. RL of the formation is constant. So here no need to subtract, means there is no need to calculate as in previous. So 49.50 they have directly given, so no need to subtract because there is no gradient given. Okay, same value for all the stations. So now 50 minus 49.50, R of the ground 50 minus 49.50, what we have to do, we have to cut. Okay, 0.50 value. So ground minus formation, if we get positive value, then we have to do it for cutting. If the ground value minus formation value, if we get negative value, then it is for banking. Okay, if you understood the concept, it will be very easy. Okay, now RL of the formation is 49.50. So 50 minus 49.50, we are getting positive value and it should be cutted down. Okay, so 0.50, similarly 1.10. Now at the 12th station, 50.30 minus 49.50, the first value we are getting as 1, and 48.50 minus 49.50 we are getting as 0.8. So whatever the 50.30 minus 49.50, we are getting positive value, so keep that is in cutting. Next 48.50 minus 49.50 will get a negative value, which is banking. For easy understanding, I am telling you in negative and positive sign, but if you imagine the problem correctly, you will get the values correctly where we have to write either in banking or in cutting. Okay, next 47.90 minus 49.50, it is banking. 1.60 we have to do banking, so here also same, we have to do banking, we have to do banking. Next, so mean height, so 0.5, 1.10 by 2. Next 1.10, we have to take this both the value which are in cutting. Okay, 1.10, 0.80 by 2, 0.95, which is cutting. Then for the ground level, here there is a drop, so what we have to do, we have to do banking. Then we have to take the value for banking. So 1 plus 1.60 by 2, 1.30 banking. So similarly, other two steps. 1.6 plus 1.3 by 2, 1.45, 1.3 plus 1.5 by 2, 1.40. So these three values we have to do for banking, and here we have to do cutting work. Okay, this was the case if the vertical drop comes in between. There is only one vertical drop at one station. Okay, what if the vertical drops comes in between two stations? If the vertical drops comes in between two stations, same way additional 2 RL level, 2 reduced level of the ground shall have to be taken at the drop. Where there is a drop, you have to take 2 RLs at the top ground level 1, at the bottom ground level 1, and the procedure is same. So this type we have to solve this type of problems for fully cutting, fully banking, and fully partly banking and partly cutting. Now the author has given for this we will solve the full problem. Here they have given example number 7. See, estimate the quantity of earthwork for a portion of a road from the L section taking the case third, partly in banking, partly in cutting as formation. Length of the chain is 50 meters. For the same data, they have found the cost. Okay, estimate the quantity of earthwork they have found and also the cost. Okay, now we'll see same tabular box. B is equal to 8, S is equal to 1.5. So slope for banking, for side slope for cutting is 1. So station 10, 11, 12, 13, 14, 15, 16. Okay, where we have to see, we have to concentrate here. Height of the bank minus 0.50, minus 1.10, minus 0.80. From where these values we have got, these are the values where we are getting here. Here are the values 0.5, 0.1, 0.80. So these are the values for height of the bank. Okay, and these are the values for same height of the bank after the station 12. Okay, these are already solved. Now for 10th station 0.50, 1.10, 0.80. Why it is taken minus? Because it is going to be cut. Okay, cutting. So now mean height, central area. So first value we have to blank. Next, what we have to do? 1.10 plus 0.50 divided by 2, 0.80. We have to take mean. Okay. Next, mean. That mean, if we after getting D, what we have to do? We have to multiply with the B, that is the formation width 8 meter. Then for banking, for doing banking, we have to take 1.5 S D square, then total area BD plus SD square, then distance, then what we are doing, the quantity is for cutting or banking, we are doing cutting, so 352.0. For 12th stain is also 0.80, 0.95, 7.60, 0.90, same method as we done in earlier. Okay, so for this 1.10 cutting, okay, plus 0.80 we are getting 0.95. Okay, 0.95. How we will get? By taking the mean of these two. Okay, and for 1.30 by taking the mean of these two for banking. Okay, so these values are in banking. So in the ground what we are doing, that we are writing here. So we will get cutting values and banking values. Okay, then what we have to do, we got the cutting value, banking value. Now cost, you do what? In the cost estimation, how? One is for two items will be there, 1 and 2, estimation of the cost. So particular of the item, so earthwork in banking, take this into the rate which I have given. Next item is earthwork in cutting, that is quantity is 777.00 into the rate which they are given. Take the total, add both the total in banking and cutting. For that total, add 5% contingencies, then we will get the grand total, and that would be the price for the cost. That would be the cost of earthwork for this problem. So we saw the problems for both cutting, filling, and partly in banking and partly in cutting. So I hope you understood. Thank you.